This week we look at conditional statements. So this is testing conditions, and then depending on what the result of that test is, we do one or another different functions. Contact details as always, please contact me if you need to. And the content for this week, we're looking at Printf to format output, looking at random numbers and conditional statements. Let's start a new script in Matlab. I'm going to save it as, let's call it display. And we can display information in different ways. So we started off looking at disp, which is the easiest one. If we run this program, it'll run the program display and it'll give me the number 42. However, I can also use the fprintf command. Now, using fprintf, I can do something slightly different. I can display it in different ways. So, if I give it the command this, it will display the number 42, but now I've got some text to explain what my output is. So what's happening here? I've got fprintf, which is a print function to the screen. I then have some text, which is enclosed in inverted commas. I then have a percentage sign $d. This is a placeholder. So when Matlab sees a percent sign within a formatted string section, it will then look for the number after the comment of the fprintf command. So in this case, it's going to replace percent sign $d with 42. D is for decimal notation. I could change this to %f and save and run this, and that will display it in fixed point notation. I could also be a bit more specific about this, and if I write it as 2.1f, this tells it exactly how many decimal places to use. I'm asking it to use 2 spaces before the decimal point and 1 space after. If I wanted to have 42.00, I would need to change that 1 to a 2. And then it would do that. So these are all different ways of using fprintf. The \n starts a new line. If I didn't do that, if I take that out, you can see it's not returning after the final text display has been given. So you should always keep this in to keep everything neat. So have a little play around. Of course, it's going to depend on what sort of data you're looking at, which will dictate what accuracy, how you want these numbers to be displayed. So make sure you always consider the most appropriate formatting to give your output. Okay, so random numbers. Let's lose this one. Let's clear the screen and the memory. I'm going to look at random numbers now. So I'll create a new M file just to look at this. We'll call it random nums. And I can create random numbers by giving the command rand, and that will give me a random number generation. It's always going to generate a different number between 0 and 1, but each time you start Matlab, it's going to give you the same first number and the same second number, the same initial seed number. It's not truly random, it's a pseudo-random. The seed value, the initial value, is always going to be the same. If you want a more random number, we can shuffle. We can shuffle those numbers. So we can do that by typing the command rng shuffle. I'll save that and run it, and it's going to give me another random number. This random number, the shuffle command, is basing the random number generated on the clock of the computer. So again, it's not truly random. It's taking whatever the time is when the command is run, and it's generating a number from that time. Not truly random. If you want to generate a number between two intervals, we have to write a code to specify that. There's not a one that will do that for you immediately. So there's an example we can follow here. I've given it in the handbook. Let's say we want to get a random number between 1 and 100, and we're looking for an integer. Matlab has lots of ways to do the same thing. You're probably realizing this already. So the quickest way to do that is to use the command called rand_i, and then open curved brackets, open square brackets, 1 to 100. Save that. And that's going to give me a random number each time I run it between 1 and 100. Another way of doing the same process would be to get a random number, and notice that the random number will always come in a value between 0 and 1. So it's going to be less than 1 each time. If we want to get a value of 100, what we could do is multiply this value by 100. So I could do rand times 100. Let's just do number is equal to random times 100. And run that. And it's going to give me a number. If I wanted an integer, I could just use the round command. That's going to round it to the nearest integer. So those are two ways of generating a number between 1 and 100. If you want to generate a non-integer random number between set limits, that's not done as a routine in itself in Matlab, but you can create a script. There's an exercise in the workbook, exercise 4.1, where you can do that. You can also create matrices of random numbers. So just as rand created an integer random number, the function is set up so that we can specify a value in brackets, and it will create, in this case, a matrix of 3 by 3 random numbers. Or I can create a matrix of 2 rows and 5 columns, etc. We're going to use a random number in the conditional statement we look at next. So let's start a new script, and this is going to follow the over-under script in your handout. Just save it as over-under m file. Don't need that there. Over-under.m. Right. This is a little game. It's going to ask the user for a number. It's going to apply an operation which involves a random number, and then the product of that will be tested against a condition, and you either win or lose. So it's part judgment, part luck. The first step is to get the number from the user. So let's ask the user to give us a number. We're going to ask the user to give us a number between 1 and 10. Enter a number between 0 and 10. So that's going to give us a number. We're going to then use a random integer and multiply that against this number to give the number that will be tested. So we have usernum, which is our product, user-defined number, multiplied by a random integer that is from -10 to 10. Now we need an if loop to test this number. So when we're making if-else statements, they're very similar to the for statements. We have an if at the beginning and we have an end at the end. and everything contained between these two instructions is within the if loop. And this is testing different conditions. So let's look at that product number, that user number, and let's see defining the winning condition. If the product of those two numbers is over 10, then we win. So I'm going to say if the user number is greater than 10, we get a little sign in the window that will say, well done, your number is, and then because we have to use the placeholder format, that's %d, and the number we want to display where the placeholder is the user num. Can I expand this a little bit so that you can see what I've written? There we go. So if this condition is true, the script is going to print this instruction. Otherwise, and now we need to use the else if function, this is a different condition that needs to be tested. If the user num is less than or equal to 10, we don't win. We print something like, oh dear, your number is placeholder D, try again. And then we need the end statement to finish that off. Let's save that. And let's run it. So I'm going to type in over under, enter a number between 0 and 10. So if I give a number 5, and you see how there's no space between the question and the answer, so let's exit that and sort that out before anything else. Right, run again. So 5. So I put the number in 5, it's generated a random number, it's multiplied them, but it's given me 25. So quite clearly it's given me -5 as my random number. And because the test condition is it has to be over 10 to win, then I haven't won. Let's try again. I'm giving myself a higher number, I'm giving myself a better chance. Great, so now my number is 80 and I win a prize. So the conditional statements are testing conditions and then executing different outcomes based on that test. So this can be useful if you're testing a large number of data. For example, if you've got a list of patients and you're looking at their blood pressure, you could extract all the patients with a blood pressure over a certain threshold and notify them as high risk, get them to come in for a check. Or if you're testing components, you're looking at the stress experienced by different components, you could have all the test results in a single file, and this might be 1 million data points, it may be a very large file. And you could test them for certain conditions. So certain components might not achieve a certain stress profile, and those components should be taken out of production line. So let's look at the extracting numbers example, because this explains this principle quite nicely. Let's get rid of everything. Nice blank canvas, a new M file. Let's call this one extracting numbers. First of all, let's define our vector of information. And this could be stress test results, or it could be span lengths, it could be anything that needs to be checked. In this case, we've got a vector of some integers. I'm going to copy across the vector. I want to get the size of this matrix because I need to be able to test all the conditions within it, so I need to know what my maximum number of elements in this vector, in this matrix. So I can do that using the size command. I think this is mentioned in previous weeks, but in case it's not, we can use this instruction here to find the size of any matrix or any vector. So the size and the vector you're testing will return two values. It will return the first number will be the number of rows, the second number will be the number of columns. We then need to initialize our result vectors, because when we run these programs several times, we don't want to have old data sitting in those matrices. So I'm going to be using something called nums over 10 because I want to extract all the values that are larger than 10. And I've got a counter which I'm going to give the value of 1. So my for loop, what I want to do is loop over all of these numbers in this vector. So I need to know the size of the vector. That's found here. If I put in vector to the command window and then I produce this, I'll show you how it gives us the information. So that is detecting that the size of the rows is 1, there's 1 row, and that there are 9 columns. So I've got 9 here, and I know that that is the number of columns in my vector. That's useful because then I can count, use my for loop to count from 1 to that number, from 1 to columns. The number that I'm going to be testing is going to be the index of the vector set by that column number, so IM. So the first loop, IM will be 1, will be the first location in the column. Second loop will be the second location in the column. So num is equal to vector IM. On the first loop, IM will be equal to 1 because it's the first column. In the second loop, it will be equal to 2 because it's the second column. And then I need a second nested loop, which is a check, a conditional check. Now I want to see if the numbers are over 10. So if num is over 10, I want to extract that and put it into a separate vector. You'll notice I've got two counters here. IM is my incremental counter counting over the columns, but my nums over 10 needs a different counter. This has got a different counter IN, and I've initialized that to 1. That is because this result vector is only going to be as long as the number of positive results that are allocated to it. If we use the IM vector again, we would have a vector that is the same size as the initial vector, but with zeros. And in this case, it would be zeros every time there is a number less than 10. So this would be 0, this would be 0, this would be 0. What we want to do is extract all the numbers that are greater than 10 and put them in a smaller vector that is only going to be 6 points long. Right, we need to then display the results. So let's save that and run it. And it's picked up something. And it's saying it can't find vector, and that's because I haven't called it vector 10. Matlab is very good at telling you what you've done wrong, so do take notice of the error messages you get because they can help you. So now it's gone to that initial vector, and it's looked at all the numbers, and it's taken out all the numbers that are over 10 and put them in that separate vector. They're all stored here in numbers over 10. So I can do something with them later on. And this could be patients at risk, it could be materials that are experiencing too much stress, it could be from fatigue or something. It could be any condition that you want to test against. And the beauty of this is that you can write a really small script. This could be the extent of it. And instead of having this vector, you could read in a data file which might be testing 100,000 components. And there's no more programming to do than this. Very, very useful technique to know about. And also something that will almost certainly come up in later years in engineering for you. That's the end of the 4 introductory sections to Matlab. Next week you'll be starting on your coursework, and I'll provide you with all the information for that next week.